Hello students, so today we will see numericals on current electricity. So in that first problem I have taken, which has appeared in March 2016 for 5 marks. So there are 3 resistors of resistance 2 ohms, 3 ohms and 4 ohms connected in series. What is its total resistance of the combination? So this part is very simple. If the combination is connected to a battery of EMF 10 volt and he says negligible internal resistance, means internal resistance is 0. Obtain potential drop across each resistance. So you are required to find V across each resistance. So first you draw circuit diagram for this. So there are 3 resistors connected in series. So there are 3 resistors connected in series across a cell or a battery of EMF 10 volt. So 3 resistors in series connected across 10 volt. So first one is 2 ohms. R1 I will take 2 ohms. R2 is equal to 3 ohms. And R3 is equal to 4 ohms. 4 ohms. Connected to a battery of EMF 10 volt. So E is equal to 10 volt. Negligible internal resistance means small r is 0. You are required to find V across these 3. So first you are required to find total current. Then you will have V1, V2 and V3. Then you will be able to find V1, V2, V3. So for circuit diagram, there will be 1 marks out of 5. So in all the problems, in first step you find total resistance or effective resistance you may say. So total resistance of the circuit. Total resistance. So these 3 are in series, therefore R will be R1 plus R2 plus R3. So total resistance R is equal to R1 plus R2 plus R3. So substitute and add. So 2 plus 3 plus 4, you will get 9 ohms. 9 ohms. This is first step. In almost all problems, first step is total resistance. And second, I will be taking from simple to difficult problems. First, initially we are seeing simple problems, then we will move for the difficult one. Second, you are required to find total current, or you may say main current. First, total resistance, then second, total current or main current, and that is given by I is equal to E by R plus R, where E is EMF, R is total external resistance, small r is internal resistance. So if you substitute, so this is equal to E is 10, total external resistance is 9 and internal resistance is 0. Internal resistance is 0. So you will have 10 divided by 9. So divide it using calculator. So if you divide 10 by 9, you will have 1.111 ampere. So total current is 1.11 ampere. This is second step. So in third step, we will find potential across each resistance, that is V1, V2, V3. In series, the total current remains same. So current here also will be I, here also it is I. Here also it is I. So V is equal to I into R. Using Ohm's law, you will be having. So third, potential across each resistance. Potential difference across resistance. Potential difference across resistance. So using Ohm's law, so you will have V1 is equal to I into R1. So I is 1.11. R1 is 2, so 1.11 into 2, you will get 2.22 volt. Similarly, V2 is equal to IR2, so 1.11 into resistance is 3, so you'll have 3.33 volt. V3 is voltage across R3, so I into R3, so 1.11 into 4, so you'll have 4.44 volt. So this is our answer. So if you add V1 plus V2 plus V3, you should get 10. So if you add this approximately, you will have 3 plus 2, 5, 9, you will have 9.99 you will be getting. Clear, students? Next we will go for the second one. So second problem. So there are 3 resistors 4, 6, 8 connected in parallel. So I have drawn here circuit diagram. So 3 resistors are connected in parallel across an EMF of 25 volt E. Again he says negligible internal resistance. So internal resistance R is 0. You are required to find total current and current through each resistor or branch current. That is, you are required to find I, I1, I2, I3. So this has appeared in July 2017 for 5 marks. So first you draw the circuit diagram, you will be getting 1 marks. Then in simplification, first you find total resistance or equivalent resistance. So total resistance. So if 3 resistors are in parallel, total resistance R is given by formula R1, R2, R3 divided by R1, R2 plus R2, R3 plus R3, R4 plus R3, R4. Now substitute in this. So R1, R2, R3, 4, 6, 8. So 4 into 6 into 8 divided by 4 into 6 plus 6 into 8 plus 8 into 4 plus 8 into 4. So again use a calculator and multiply these and simplify. So if I simplify that, if you multiply 4 into 6 into 8, so you will have 192. And denominator, if you simplify, you will get 104. So if you simplify denominator, you will get 104. If you divide, you will have resistance 1.846 ohms. So resistance will be 1.846 ohms, that is external resistance. First step. In second step, find again total current. So in all the problems, almost steps remains the same. So second, total current. Total current. So total current I is given by E by R plus R. So substitute the values. E is 25, capital R is 1.846, small r is 0. So 25 divided by 1.846 plus 0. So if you divide, use a calculator, you will have total current 13.54 ampere. 13.54 ampere is the total current. Clear, students? Now, in third step, we will find current across each resistance. That is, we will find branch current. Current across each resistance, or we call it as a branch current. Now remember, students, if internal resistance is 0, then whatever voltage over here it is there, that is EMF, it will be same across these 3 resistors. Means when R is equal to 0, V is equal to E. That is, terminal potential difference will be equal to E, and in parallel voltage remains same. Voltage remains same. So you can say as R equal to 0, V1 is equal to V2 is equal to V3, and that is equal to 25 volt. That is voltage or EMF of this cell. Now use Ohm's law and find branch current I1, I2, I3. So by Ohm's law, I1 is equal to V1 by R1. So V1 is 25, R1 resistance is 4. So you divide 25 by 4, you will get 6.25. 25 divided by 4, you will get 6.25 ampere. Similarly, I2 is equal to V2 by R2. So again V2 is the same. Second resistance R2 is 6. So you will have 6 4s are 24. 4 point divide using calculator, you will get 4.16 ampere. Similarly, I3, V3 by R3. So V3 is again 25, R3 is 8, 25 by 8, 8 3s are 24. So you will get 3.125. So you will have 3.125 ampere. This is our branch current. So check whether answers are correct or wrong. How we check is total branch currents should be equal to total current. So sum of branch current. So if you add these three, use calculator and add these three. Roughly if I add 6 plus 4, 10, 10 plus 3, 13, 13 point something. So you will have, so almost you are getting same. So these values are correct. Clear, students? So you can note down. Next we go for the third one. So third one, students. So he has given the circuit diagram in the question. He has asked us to find main current and current across these two resistors, that is 12 ohm and 6 ohm. So it's very simple, as good as the last problem. So if I take solution, so I will take this diagram only over here. So this I will take it as R1, 12 ohms. So 6 ohms I will take it as R2. EMF is 12 volt. He has not given internal resistance, means small r is 0. So he has asked us to find main current. I you are required to find, and current in 12 ohm and 6 ohm, that is I1 and I2. So again, as we have solved last two problems, first step will be total resistance. So first find total resistance or effective resistance. So total resistance. So in this two resistors are in parallel. So R is given by R1 into R2 divided by R1 plus R2 for parallel. R1 into R2 by R1 plus R2. So if I substitute 12 into 6 divided by 12 plus 6. So 12 into 6 divided by 18. So if you simplify, 6 3s are 3 4s are, so you will get 4 ohms. R is equal to 4 ohms. This is our first step. So second step, you are required to find total current. So in second step, total current. So total current is given by formula I is equal to E by R plus R. E divided by R plus R. So E is 12, capital R is 4, small r is 0. So if I substitute 12 divided by 4 plus 0, so total current will be 3 ampere. So total current is 3 ampere. Clear, students? Now again you are required to find I1 and I2, that is branch current. Again in this problem, if you observe, small r is 0. So if internal resistance is 0, voltage across these two resistors will be same and it will be 12 volt. So in third step, I will calculate branch current. Branch current. So to calculate branch current, as R equal to 0, V1 is equal to V2 and that will be equal to 12 volt. Now use Ohm's law. So using Ohm's law, I1 is equal to V1 by R1. V1 is 12, R1 is 12, so you will get I1 as 1 ampere. Similarly I2 is equal to V2 by R2, so this is again 12, R2 is 6, 12 by 6 you will get 2 ampere. So in last problem I told how to check whether it is correct or wrong. If you add branch currents you should get total current. So here 1 plus 2 is 3, so it's correct. So you can again note down this. We'll go for the next one. So fourth one, students. Here again he has given circuit diagram and he has asked us to find current in 9 ohm resistance. Now here if you observe, there is internal resistance. In last problems, negligible internal resistance was there. So in this problem, we are having internal resistance. So first, I will draw simplified circuit so that it will be easy to solve. So if you observe here, these two are in series. So their effective resistance will be R1 plus R2. So if you add these two, you will get 6. So in first branch, there is a 6 ohm resistance. So R1 is equal to 6 ohms. I will take. In second branch, this 6 and 6 are in series. So if you add, you will get 12. So in second branch, resistance is 12 ohms. So R2 is equal to 12 ohms. In third branch, 9 ohm resistance is there. So this I will take it as 9. R3 is equal to 9. These are connected across a cell. They are connected across a cell of EMF and internal resistance. So I will take E is equal to 3 volt and internal resistance is 0.24 ohms. So you are required to find current in 9 ohm resistance, means just I3 has asked. So before that you are required to find total current. So I will need to find. So again steps remains the same. In first step you are required to find total external resistance, that is 3 resistors are in parallel. So in first step find total resistance or total external resistance. So if I take total resistance, R is equal to R1, R2, R3 divided by R1, R2 plus R2, R3 plus R3, R1. So substitute the values. So 6, 12, 9. So 6 into 12 into 9 divided by R1 into R2, 6 into 12 plus 12 into 9 plus 9 into 6. So simplify. If you multiply numerator, so numerator you will get 648 divided by, simplify denominator using calculator. So if you simplify you will get 234. So this is 234. Now again divide these two. So if you divide, you will have 2.76. 2.76 ohms. This is total external resistance. Now second step, correct. You are required to find total current I. So in second step, total current. Total current I is equal to E by R plus R. So if you substitute, E is 3. So 3 divided by external resistance 2.76 plus Here internal resistance is there 0.24. 0.24. So add and simplify. So this is 3 divided by. If you add 24, so again denominator will be also 3. So you will get 1 ampere. Total current is 1 ampere. Clear, students? Now you are required to find branch current or current across 9 ohm resistance. Here you cannot take directly V as 3 volt. If R was 0, V was directly equal to 3. Here internal resistance is there. So first you should find terminal potential difference. So if R is there, that is not equal to 0. So you are required to find terminal potential difference, means V you are required to find. So to remember here I will write when R is not equal to 0. So using Ohm's law, V is equal to I into R, where I is total current, R is total external resistance. So total current is 1, total external resistance is 2.76. So if you multiply V, you will get 2.76 volt. 2.76 volt. So now in fourth step you will get branch current or I3. Branch current or current through 9 ohm resistance. So now these three are in parallel. So voltage across these three will be same, that is V1 will be equal to V2 and will be equal to V3, and that will be equal to 2.76 and not 3. That will be equal to 2.76. So V1 is equal to V2 is equal to V3 equal to V 2.76 volt. So therefore again by Ohm's law, I3 is equal to V3 by R3. V3 by R3. So V3 is 2.76, R3 is 9. So you divide it by 9 using calculator, you will get current. So if I divide it by 9, I am getting 0.306 ampere. 0.306 ampere. Clear, students? So this is applicable when R is not equal to 0. Again you can pause, note down this solution, we will go for the next one. So students, again in this problem, he has given circuit diagram and asked us to find total current in the circuit. So it means you are required to find total current I. So this has appeared in July 2019. So in this diagram only I will note down. So this I will take it as R1, R2. This I will take it as R3, R4, R5. And internal resistance I will denote it as a small r. Small r is equal to 1 ohm. This is E. He has given 16 volt. So first we are required to find total external resistance, or I will take it as a total resistance. Total resistance. Now to simplify this circuit, first you are required to simplify these two resistors, that is R1 and R2. Then R4 and R5, then these three will be in series. So if I take these two, 4 and 4, these two are in parallel. So effective resistance of R12 I will write it as R1 into R2 by R1 plus R2. So R12 is effective of these two, that is R1 and R2. So if I substitute 4 into 4 divided by 4 plus 4, that is 16 by 8. So this is equal to 2 ohms. This is equal to 2 ohms. Similarly, I will simplify R4 and R5. These two are in parallel. So R4 5 is equal to R4 into R5 divided by R4 plus R5. If I substitute 12 into 6 divided by 12 plus 6. So 12 into 6 by 18. 6 3s are 3 4s are, so you will get 4 ohms. You will get 4 ohms. So now the simplified circuit of this will be, here I will be drawing simplified circuit. So now I will have 3 resistors connected across a cell. So this is 2 ohms, R12 2 ohms, R3 is 1 ohm, then R45 is 4 ohms, total current I, this is E16 volt and internal resistance is 1 ohm. So now if you observe, I have simplified these two, effective of these two is 2 ohms. I have simplified these two, 6 and 12, effective is 4. Now these 3 are in series, so therefore you will get R is equal to R12 plus R3 plus R45. Substitute and add 2 plus 1 plus 4, so 4 to 6 plus 1, 7 ohms. This is effective external resistance. Now in last step, you calculate total current. So formula for total current is I is equal to E by R plus R. So in second step, total current I is equal to E by R plus R. So E is 16, capital R is 7, small r is 1. So 16 divided by 7 plus 1. So 16 by 8, that is equal to 2 ampere. This is our total current. Clear, students? So again in next video